Today we are going to take a backward dive as far as possible to discover the most massive galaxies in the known universe. Starting with one of the smallest galaxies ever discovered, the Compa galaxy, which is barely 1,400 light-years across, is actually tiny compared to Zwicky 18. A dwarf galaxy containing barely a few million stars and spanning 5,200 light-years. It is itself relatively modest in size compared to the small Magellanic Clouds. And everything we've just talked about seems dwarfed by the monumental size and especially the brightness of an irregular dwarf galaxy undergoing intense star formation, such as NGC 4449. This galaxy, which still contains several billion stars, is also called a dwarf galaxy. A name that makes perfect sense when you know that it is 6 times smaller than our galaxy, the Milky Way. But let's continue our ascent with NGC 4485, which is distorted here, pulled in and connected by a bridge of gas, to its imposing neighbor, the Cocoon Galaxy, which is comparable in size to the Triangulum Galaxy and its roughly 40 billion stars. Or even to the Sombrero Galaxy, which has an astonishingly intense core, giving it a hat-like appearance. Pourtant, even though these 3 giants of space are impressive, they are still considered relatively small galaxies, with their size being about half that of our Milky Way. So what can we compare their size to? But let's continue our journey into the realm of the immense, starting with the photogenic irregular galaxy M82, next to which we would pale in comparison. Because even though it is 2.5 times smaller than our own, M82 is, due to the exceptional rates of star formation taking place there, 5 times more luminous. Here in this image, each red layer of torn clouds can contain thousands of suns being born. And here now, extremely turbulent, is NGC 3081, a strange barred lenticular galaxy with a core, within which the turbulent activity of a supermassive black hole with about 10 million solar masses has led to the formation of a resonance ring. A galaxy whose dimensions are comparable to M94, a sparkling spiral, also about twice as small as the Milky Way, and whose central core, fueled by the gas plunging into it, has turned into a fireworks display. Just like the core of the slightly larger NGC 922, a spiral torn apart by past galactic mergers, and of a size comparable to NGC 1672, which, intersected by a bar, also has an extremely bright core, the site of intense activity. Now, make way for the impressive size of the magnificent Whirlpool Galaxy, captured as it absorbs its small neighboring satellite galaxy, NGC 5195. In this image, each blue dot is a cluster containing thousands of newly formed stars. And this doomed pair could easily fit inside our galaxy, the Milky Way. It must be said that with its diameter of about 100,000 light-years, it alone is able to rival the Seyfert sextet, which you can now see here compared in size. And yet, as immense as it is, and despite the 200 to 400 billion stars it contains, our galaxy is, in a sense, just one among many others, which, although they may look extremely different, are in similar ranges of mass and size, such as the impressive active nucleus elliptical galaxy, NGC 5128, or the whale spiral galaxy, seen edge-on in profile. Just like this pair of 2 galaxies in the process of merging, which together are slightly larger than our galaxy, and of a size comparable to the typical elliptical galaxy Hogue, surrounded by its strange ring of blue stars, which is just slightly smaller than that of the imposing Cartwheel Galaxy. As for the barred spiral NGC 1300, which is also 130,000 light-years wide, it has a bar connecting its arms to its core, so large that you could easily fit them lined up inside it. All the dwarf galaxies we have, and in fact as impressive as they may be, all these galaxies are in a sense also dwarfs in the land of giants. They are mere sketches of gigantism compared to the mind-boggling beasts we will eventually encounter as we continue our ascent. Starting with the giant elliptical with dust rings, NGC 7049, and the barred spiral NGC 1097 seen here in the infrared spectrum. Or the giant spiral galaxy known as the Needle, also observed edge-on. And all of them are 1.5 times wider than our Milky Way, yet still much smaller than the barred spiral NGC 1365, the colliding galaxy pair ARP 81, or the immense filamentary elliptical galaxy Fornax A. And these three galaxies themselves are all slightly smaller, if that word still has any meaning, than our massive neighbor, the Andromeda Galaxy, with which we will collide in a few billion years. And now we're starting to enter the world of galaxies that we could call golden. Category, with the impressive barred spiral NGC 4921 and the elliptical galaxy NGC 474 with gas shells, which owes its very peculiar tidal tail shape to the fact that, in its recent history, it too has absorbed a number of small galaxies, just like that of the Tadpole Galaxy, whose one arm was literally torn apart following a violent interaction, to the point of leaving behind a sort of gigantic galactic tail, about 280,000 light-years long and rich in clusters of extremely massive blue stars. And this barred spiral that has spread out, as impressive as it is, doesn't compare to one of the largest known spiral galaxies, NGC 6872, which, with its stretched arms, is by itself at least 4 times larger than our Milky Way. Interacting with its neighbor IC 4970 together, they form a pair nearly 500,000 light-years across. An insane size, comparable to that of Cygnus A, an elliptical radio galaxy emitting powerful radio waves, and slightly smaller than the enormity of Malin, one which, surrounded by a huge pale halo, alone measures 650,000 light-years across. In reality, Malin 1 is so monumental that you could easily fit the interacting pair of spiral galaxies known as ARP 273 inside it several times over. And yet, even though it is currently the largest spiral galaxy in the known universe, Malin 1 is still relatively small compared to the extravagant size of the giant elliptical galaxy. M87, which, among the queens of the super heavyweight class, has a mass 200 times greater than that of our Milky Way. Here it is shown in a size comparison. To reach such a size, M87 had to swallow and merge with dozens of other galaxies over its history, eventually reaching nearly 1,000,000 light-years in diameter. And yet, M87 is still not the largest. It too is just a hint of gigantism when compared to the colossal Hercules A. This galaxy also contains impressive amounts of matter and energy coming from a hyperactive black hole hidden at its center. Hercules A is not only 15 times larger than our galaxy, it is also extraordinarily heavier than everything we've just talked about, combined. Yet, even though it weighs a few thousand times more than our Milky Way, Hercules A is still not the largest. It is still only half as heavy and 1/4 as extensive than what remains to this day the largest of all galaxies in the known universe, the astonishing IC 1101. A monster harboring more than 100 trillion stars towering over and eclipsing all the galaxies we've just mentioned. Because in terms of brightness, IC 1101 is to our Milky Way what a forest fire is to a lighter's flame.
In short, you get the picture.
It's gigantic and also incomplete, because we've only placed a few dozen galaxies there, while our universe contains something like 2 trillion. 2 trillion galaxies that, in reality, are absolutely not stuck together. And even though you can find hypergiant ellipticals like M87 Hercules A, or even IC 1101 at the heart of galactic clusters, which, over time, by swallowing and engulfing a considerable number of their neighbors, have managed to reach such enormous sizes. Galaxies as a whole still remain extremely spread out across the universe. And as immense as they are, all of them, without exception, are ridiculously small compared to the universe as a whole. And to think even bigger, to try to grasp its immensity, let's return to the scale of our Milky Way and its imposing neighbor, Andromeda, which we represent here side by side. And while the size proportions are accurate, the distances separating these two galaxies are not. And when they are, when 2.5 million light-years separate the two spirals, as is the case in reality, we realize that space truly lives up to its name. Between Andromeda and our Milky Way, it would actually be possible to literally fit almost all the galaxies we've previously talked about. And yes, it would take an entire episode to do justice to the extraordinary, enormous distances that separate us from those other island universes that are galaxies. And we will do it. But in the meantime, let's give the final word to the immeasurable IC 1101 by placing it for fun between us and Andromeda.